how to use bootstrapping for multi-level model or linear mixed effects model using the LME4 package in R. If the normality assumption is violated for your model, then bootstrapping can be a solution. And it's quite easy to get bootstrapped confidence intervals for an analysis with the LME4 package. The example dataset sleep study is part of LME4, so you can run the same analysis yourself. It's an experiment about sleep deprivation, so we have the subject ID, the day of the experiment, and the reaction time. And we want to analyze how the reaction time gets longer with an increasing duration of sleep deprivation. For technical reasons, the days number 0 and 1 are not relevant, so I filter them out. And then I run the normal mixed effects model with the LMER function. The reaction time is predicted by the intercept and the number of days, and the random effects, a random intercept, and a random slope for days. Here we have our results. And now we would like to get bootstrapped confidence interval as a robust parameter test for the fixed effects and for the random effects. Random intercept, random slope, residual error, and random correlation between random intercept and random slope. Now we run the bootstrapping. Since bootstrapping is a random process, I recommend setting a seed value, that is a starting value for the random numbers generator, so that each time you run the analysis with the same data, you will get the same results. What number you put into this function doesn't really matter. The important part is that it's always the same number. Then to the confidence interval, we start with putting in the result we got from the LMER function, method boot for bootstrapping, boot type percentile, the confidence level, number of bootstrap samples, and lastly, old names equals false, because the new names for the results are much easier to read and to understand. Now we can run this, and it will take a minute or two, because the analysis is repeated 5,000 times. Now we can look at the results. First we get warning messages. Some of the 5,000 bootstrap samples led to non-convergence. That is, 79 of the 5,000 runs did not result in a valid model. And that's something you should report. Then to the results. Down here are the fixed effects, confidence interval for the fixed intercept, and more relevant, the confidence interval for the fixed slope for days. The confidence interval for days does not include the 0, so we have a significant effect of the number of days on the reaction time. The other parameters about random effects. As the intercept conditional on the subject, that's the random intercept. So this is the confidence interval for the random intercept. As the days conditional on subject is the random slope for days. So we have a significant random slope. Core days intercept. This is the random correlation. This parameter here. So the correlation between the two random effects. And here we can see this correlation was not significant. And as a last random effect, the sigma, that is the random error on level 1, that's not terribly interesting. And if you report your model, you would report those confidence intervals in addition to the parameter estimates. Thanks for watching and see you in the next video.